Customer Case 5. Problem Introduction.
Our long-term client from mass production industry invented concept of advanced rotary high-speed micro-cutting machine. His major concern was, is the conceptual idea valid to produce this mass production machine? Producing such mass production machine is very expensive and resource-consuming, and therefore, solid proof validity of this conceptual design is critical before making investment in this innovation project. The micro-cutting process based on interaction between the rotating tool mechanism and the cut material. The cutter itself penetrates the material until it meets impact absorber. Here the cut material and bottom impact absorber both absorb impact kinetic energy within a fraction of millisecond, and therefore, high-speed dynamic cutting force is produced. When dynamic cutting force exceeds its maximum design value, the cutter is overloaded by excessive compressive stress and fails by brittle fracture. Correct concept idea must guarantee that compressive stress in the cutter must be low enough to withstand millions of micro-cutting cycles. The goal of the RFEA expertise project was to model the cutting process and choose appropriate design parameters in order to validate the cutting process and to achieve structural safety of the cutting tool.
Simulation and problem identification.
Precise FEA model of rotating micro-cutting tool assembly, including effective material cutting, was created with appropriate tolerances and contact interaction between parts. Brittle material model to identify fracture during cutting process simulation was set up with appropriate parameters taken from brittle material data sheet. After FEA modeling was complete, our FEA expertise performed dynamic impact simulation of the high-speed micro-cutting process. The micro-cutting impact occurred in a fraction of millisecond, and therefore, slow-motion observation of the impact process was done by creating animated simulation results. Cutter fracture was identified due to high impact velocity. Additional optimization trials of micro-cutting tool parameters didn't help to avoid fracture, and we concluded that different concept idea must be proposed.
Problem solving.
Our expertise provided solid proof conclusion to our customer that investment in this invalid concept would be a serious mistake and different reliable concept must be proposed. Next FEA expertise project for different micro-cutting machine process concept was performed in collaboration with another team in this company. The second micro-cutting concept was really smarter than first. Here the cutter impact was driven by electromagnetic force and allowed to better control impact load on the cutter. Precise FEA model of the rotating micro-cutting tool assembly, including effective material cutting, was created for the second concept, with the capability to apply electromagnetic load on the cutter gradually with time. The FEA expertise results proved validity of this second concept after finding best design parameters. Mostly electromagnetic load versus time. The chosen parameters ensure that compression stresses developed in the cutter was far below the material ultimate compressive stress. The whole project was performed in customer's time schedule.
This customer benefited from our FEA expertise in
1. Studying lesson on impossibility to validate his high-speed micro-impact process idea without high-end FEA expertise. 2. Visual understanding how high-speed impact deformation develops in fractions of millisecond. 3. Developing intuition how design parameters affect high-speed impact deformation process. 4. Checking each set of design parameters and finding the best one.
Testimonial. Project manager, employed our FEA expertise for last 3 years.
The FEA expertise have helped us greatly in preventing large financial losses by examining our conceptual design, well before going into the production and integration phase. We would love to work with you later.
Testimonial. R&D manager, employed our FEA expertise for last 3 years.
The process was carried out in a professional and meticulous manner, during which we learned a great deal about a complex high-speed dynamic impact process, which without this expertise, we were not able to comprehend.
End of Customer Case 5.